Chapter 5, Short-Term Memory. I didn't realize there was so much controversy about short-term memory. I've always taught it as a more definitive form of memory, but evidently there's a lot of conflict as to how it's put together. So we'll talk about it. I'll try to leave as much of the conflict out of it as possible. We will agree that there is short-term memory. Well, there are some researchers that think that short-term memory is part of long-term memory, or the working memory is part of the long-term memory. It's just the long-term memory short form or something. Anyway, well, let's get into it. So I'll try to leave all the conflict out. That's just the way I am, I guess. William James in 1890 suggested that there were two separate stores, one for items being held briefly in conscious awareness and the other for items held for longer periods in unconscious storage. They subsequently became known as short-term memory and long-term memory. James felt that conscious memories seem different to the memories in storage and seem to have different characteristics. James' theories between short-term memory and long-term memory remains plausible to this day, and so we do agree that there is short-term and long-term memory. The questionable part is the working memory and long-term memory. That working memory is part of long-term memory, but we won't really talk about that very much. Short-term memory refers to the memories which are currently receiving our conscious attention, and it is a temporary store of very brief duration and limited capacity. Long-term memory refers to the memories which are not presently in conscious awareness, but which are held in storage ready to be recalled. A long-term memory store has a very large capacity and can hold information for a lifetime. According to Atkinson and Shiffrin model, information is held in short-term memory by continually rehearsing it, and without rehearsal, it will be almost immediately forgotten. The long-term memory is seen as a more passive store of information, which is available for retrieval but not kept in an activated form. Earlier models of memory storage had seen the short-term memory as little more than a port of entry into the long-term memory, but in the Atkinson and Shiffrin model, the short-term memory store is also used for retrieval of memories from storage. The Atkinson and Shiffrin model includes a third store, which is seen as a very brief preliminary store for unprocessed sensory information, essentially an afterimage occurring in the sense organ itself. There is some evidence for such a brief sensory store, but the short-term memory and long-term memory are of far greater importance to memory function. And we'll talk about the sensory memory, this short sensory store, in just a minute. Most people refer to it as the working memory. Over the years, evidence has gradually accumulated in support of the dual store theory, the most convincing evidence coming from the study of amnesic patients. Those suffering from organic amnesia, a memory impairment caused by physical damage to the brain, have difficulty forming any new long-term memories, but their immediate short-term memory is usually unimpaired. Such patients are able to remember what has happened during the previous few seconds, but not for earlier time periods. The finding that short-term memory can remain intact despite severe impairment of long-term memory suggests that they are separate and independent memory stores. Ebbinghaus in 1885 demonstrated that memory for a list of items is affected by the serial position of an item in a list. Items at the end of the list are particularly well remembered. This is known as the recency effect. And to a lesser extent, items at the start of the list also tend to be remembered, and that's known as the primacy effect. However, items in the middle of the list are more likely to be forgotten, and that's why we have these lines. We remember the early items, we remember the final items, but we forget the ones in the middle. Ebbinghaus suggested that items in the middle of the list might suffer more interference, which could explain why the items in the middle are less easily remembered. However, an explanation for the recency effect, the last few items on the list, are probably remembered because they are still in the short-term memory at the time of recall. This theory received support when a delay was introduced between learning a word list and recalling it. A delay of 30 seconds filled with a simple task to prevent participants from rehearsing the word list was found to be sufficient to completely eliminate the recency effect. A number of different explanations have been suggested for the primacy effect. There is some evidence that items at the beginning of a list benefit from greater attention than those later in the sequence. It has also been shown that the retrieval of the first items on the list may exhibit the retrieval of subsequent items, a phenomenon known as output interference. We can get a good indication of the duration of short-term memory storage by studying amnesic individuals who are unable to transfer information to the long-term memory. Short-term retention periods have been reported for other amnesics for a few seconds. When rehearsal is prevented, the test items are forgotten very rapidly. Most items have been forgotten within 5 to 10 seconds of being presented. These results suggest that short-term memory storage requires rehearsal to keep an item in consciousness, and if rehearsal is prevented, the item is lost from the short-term memory very rapidly. Muter in 1980 showed that most items are forgotten within 3 or 4 seconds if the subject is not expected to be tested. Muter argues that this is probably a more accurate estimation of short-term memory duration, since the use of an unexpected test may help to eliminate the contribution of long-term memory. The average normal person has a maximum digit span of about 7 digits, and in fact their maximum span for letters or words tends to be fairly similar. There is some variation among the general population, with scores varying typically from 5 to about 9 items. Immediate memory span is no longer thought to be a pure measure of short-term memory, since there is evidence that the long-term memory may make some contribution to span performance. In particular, information stored in the long-term memory may facilitate the chunking of several items into one meaningful item, like a telephone number. Baddeley and Hitch, and we're going to talk, Baddeley and Hitch came up with a theory of short-term memory, and Baddeley and Hitch are all through they did this in 1974. It was in a chapter in a book. This concept of the working memory and the short-term memory and the function of the short-term memory. You can quote Baddeley and Hitch from 1974 over and over and over again. They're all throughout this chapter. They are the ones that people are usually arguing with, saying that they're incorrect. So Baddeley and Hitch, of course, are icons of working and short-term memory. Baddeley and Hitch ask themselves the question, what is short-term memory for? They concluded that it must perform some function beyond mere storage, most probably involving the processing of information that it holds. Baddeley and Hitch argued that the short-term memory was more than just a temporary storage space, and that it functioned as an active working memory, a kind of mental workspace in which a variety of processing operations were carried out on both new and old memories. Baddeley and Hitch in 1974 regarded the working memory as a workspace where analysis and processing of information would take place. They reasoned that such processing would require some means of holding information while it was being processed, but their research suggested that there was more than one short-term store, as the evidence showed that there were separate working memory stores for visual and auditory material. This research made use of the dual task paradigm, in which the subject has to carry out two working memory tasks at the same time. They found that two simultaneous working memory tasks will disrupt one another severely if both tasks involve auditory input, or if both tasks involve visual input. However, a visual working memory task and an auditory working memory task can be carried out simultaneously without greatly disrupting one another, suggesting that they probably make use of two different stores. The disruption caused when both tasks involve the same sensory modality is assumed to result from competition for the same stored space. Badley and Hitch concluded that the working memory must have separate stores for visual and auditory information. They proposed a model of working memory comprising a phonological loop, which holds auditory and speech-based information, and a Visuo-Spatial Sketchpad, which holds visual information. The central executive controls working memory processes and is served by the two short-term stores. The phonological loop provides brief storage for auditory input, such as spoken words, and it is assumed to be the mechanism underlying measures such as digit span. Badley and Lewis in 1981 found that the immediate recall of a list of spoken words is severely disrupted by the simultaneous performance of a second verbal task, even one which requires no significant thought or processing. That's from what's the movie? Wait a minute. Bilbo Baggins, The Fellowship of the Ring. Potato. He says it. He spreads out the syllabi. I mean the syllables. Syllabi. Experiments have confirmed that short-term visual recall is severely disrupted by performing a second visual task at the same time, but is not disrupted by performing a non-visual task. Logi in 1986 found that the ability to learn words by using visual imagery was greatly disrupted by a second visual task, but not by a speech task. Logi et al. In 1989 reported that performance on a visual computer game was disrupted by a second visuo-spatial task. Robbins et al. In 1996 found that the ability to recall positions on a chessboard was disrupted by a secondary spatial task, manipulation of the keypad, but not by a task involving the repetition of words. There is also some clinical evidence for the existence of a Visuo-Spatial Sketchpad. With Williams syndrome, the main symptom appears to be an impairment of visuospatial processing and the Visuo-Spatial Loop, but with normal verbal processing. An interesting finding is that although Williams syndrome individuals perform normally on tests of grammar comprehension, they do in fact exhibit an impairment for grammatical structures which denote spatial positions such as above, below, or shorter. And this is an individual with Williams syndrome. She has the classic face of a person who has the genetic problem of Williams syndrome. The phonological loop is assumed to be the mechanism underlying tasks such as digit span or word span, which was previously believed to have a limit of about 7 items. However, Badley et al. In 1975 found that the word span limit is greater for short words than it is for long words, a phenomenon known as the word length effect. The finding led them to suggest that the phonological loop is limited not by the number of items it can hold, but by the length of time it takes to speak them. The word span was found to be limited to the number of words that could be spoken in about 2 seconds. Holm et al. In 2004 suggests that the word length effect may depend more on the nature of the test items rather than merely their length, since the word length effect disappears when very complex and distinctive test items are used. While the phonological loop is assumed to hold verbal items, there is some uncertainty about whether it also deals with non-speech sounds, such as the sound of a barking dog or a telephone ringing. Verbal and nonverbal material appear to use different systems. Salome and Badley in 1982 reported that background speech caused disruption of verbal memories, but non-speech sounds did not cause such disruption. This phenomenon is known as the irrelevant speech effect. They concluded that verbal material enters the phonological loop, but non-speech sounds do not. The exact mechanism involved in storage and retrieval of non-speech sounds remains uncertain. Studies have suggested that the phonological loop's main function may involve the use and development of language. Badley and Lewis in 1981 found that articulatory suppression interfered with the subject's ability to detect errors of logic or word order in a sentence, suggesting that the main function of the phonological loop may be to hold on to a sentence for long enough to analyze it for logic, word order, and overall meaning. Patients with severe impairment of the phonological loop often have difficulty in understanding long and complex sentences, but have no trouble with short and simple sentences. It seems that their problem is not one of comprehension, but an inability to retain and examine a long sentence. Other studies have found evidence of reduced phonological memory performance in children with language problems and in normal children with poor linguistic ability. Badley in 1986 suggests that the latest evidence indicated that the phonological loop contains two separate components. These are the phonological store, which stores auditory information, and the articulatory control process, which allows subvocal rehearsal of the information. The articulatory control process is seen as a kind of inner speech mechanism linked to speech production and also helps to maintain verbal information in the phonological store. Badley et al. 1984 discovered that articulatory suppression eliminates the word length effect for visually presented words, but not for spoken words. In order to explain this finding, Badley et al. Suggested that articulatory control process is required for registering visually presented words and transferring them into the phonological store, whereas auditory presented words gain direct access to the phonological store since they are already in the appropriate format. Visually presented words also use the articulatory control process, but auditorily presented words do not. This would explain why articulatory suppression will affect the input of visual presented words, but not spoken ones. The word length effect is seen as being a function of the limited space available in the articulatory rehearsal process, so this will also be eliminated by articulatory suppression. This Worms, Roxanne Worms, is a line from Roxanne, the movie, with Steve Martin. Funny movie. One of my favorites. It's a rom-com. I'm a sucker for romantic comedies. Logi in 1995 suggests that, like the phonological loop, the Visuo-Spatial Sketchpad also contains two subcomponents. These are the visual cache, which stores visual information about shapes and colors, and the inner scribe, which holds spatial information and assists with control of physical actions. The episodic buffer is assumed to integrate information from a variety of sense modalities and provides a link between the working memory and the long-term memory. Alzheimer's patients may have an impairment of the episodic buffer itself. Alzheimer's patients have a specific impairment of feature binding, as they can retain information about individual features such as color and shape, but they cannot integrate and combine them. This is consistent with the assumed function of the episodic buffer as a mechanism for binding together the different features of the input. Central executive is thought to have overall control of cognitive processing, and it is probably the main focus of conscious awareness. It also controls the phonological and visuo-spatial loops and uses them to help with processing. Miyake et al. In 2000 identified three main central executive functions. The three factors identified by Miyake et al. Were inhibition, suppression of a dominant response, shifting, switching attention between different tasks, and updating, monitoring stored information and new input. Certain brain lesions appear to cause an impairment of central executive function, so that patients have difficulty in producing controlled and flexible responses and instead rely on automatic processing and stereotyped responses. This type of impairment is known as dysexecutive syndrome, and it is mainly associated with frontal lobe lesions. And this is a frontal lobe right here. This is a frontal lobe. Impaired executive function has been described as a wide variety of different conditions, including Alzheimer's disease, Tourette's syndrome, autism, and attention deficit hyperactivity disorder. Most of these conditions are known to involve frontal lobe dysfunction. Wynn et al. In 2015 note that the working memory model has been used widely to improve language learning in educational settings, and Cashel et al. In 2009 report that a test of working memory dual task performance provides a useful means of detecting the early onset of Alzheimer's disease. Kalman in 2005 has proposed that working memory is simply that part of the long-term memory which happens to be activated at a particular moment, rather than being a totally separate memory system. Working memory, therefore, depends on which part of the long-term memory we are directing our attention to at that point in time, before we shift our attention to some other part. This is known as the embedded processes theory, as the activated memory and attentional control mechanisms are seen as embedded within various other storage systems and mechanisms. Working memory and long-term memory tasks do appear to activate the same areas of the cortex. Functional MRI research of word lists shows similar levels of temporal lobe activation found for the most recently presented items assumed to be held in working memory, and earlier items assumed to be held in long-term memory. Further support for the embedded processes theory comes from the observation that working memory and long-term memory appear to involve similar representations in memory, as working memory and long-term memory traces contain a similar level of precision and detail. Turner and Engel in 1989 found strong correlations with measures of cognitive performance when they employed operational span working memory tasks, span tasks which require additional processing such as reading or calculating. Operational span tasks have been found to correlate highly with cognitive abilities such as language comprehension, fluid intelligence, and academic performance. Measures of visual working memory account for more than 40% of the variance in fluid intelligence. Kane and Engel in 2002 suggest that the main feature of working memory performance, which predicts such cognitive skills, is the ability to control the contents of consciousness. A low span indicates poor control of attention and an inability to suppress unwanted items, and will impair performance on the wide range of cognitive tasks. Rosen and Engel in 1998 found that complex working memory measures predict whether an individual will be successful in suppressing intrusive thoughts. Now, you may be wondering, why in the world is everybody doing all this research on working memory and long-term memory and short-term memory? And the answer is Alzheimer's disease. They're trying to figure out Alzheimer's disease and why people lose their memory. So there's a lot of money out there for people working on these tasks, looking at these aspects of memory. Miyake and Friedman in 2012 have shown that several measures of central executive performance correlate with behavior in real-life settings, especially the ability of an individual to control their cognitive processes and the level of self-control and willpower that they will show in everyday life. We're talking about willpower here, and we're talking about self-control. This is really important because this is why people have problems. They have problems because they can't control themselves. Central executive scores predict successful control of diet, exercise, and weight, and they even predict the likelihood of expressing racial prejudice or committing an act of infidelity to a spouse or partner. In other words, it's central executive scores, practicing the ability to control things in your life. That's what we're talking about. So if you have a problem with being prejudiced, or have a problem with fidelity, or have a problem with your weight, potentially this is a problem of the central executive, and you need to control. You need to control that as much as possible. So the idea is that the more you can control your executive, your central executive, the better you are at controlling everything in your life. So you might think of practicing, controlling. My favorite drink is Code Red, so I need to control that because Code Red has a lot of sugar in it. So what I will do is I will try to control that, and if I can control that, then the probability that I will have prejudiced thoughts or try to mess around on my wife is less likely because I have control over my own thinking processes. It has also been reported that the tendency to worry is related to weak executive performance. And this is really something interesting because individuals, the reason that people worry is because they're afraid that something is going to happen that they won't have control over. That's why they worry. And the reason that they do this is because they have seen that they don't have control over things in their lives. Sorry that I'm showing you this lady looking at her belly fat, but this has to do with weight control that we were talking about before. Smith et al. In 1996 used PET scan imaging to show that verbal working memory tasks mainly produce activation in the left hemisphere. Visuo-Spatial working memory tasks activate regions in the right hemisphere. Brain imaging studies of verbal working memory tasks have shown that use of the articulatory control process produces activation of a part of Broca's area in the left frontal cortex. Left frontal cortex. Use of the phonological loop leads to activation of a region at the edge of the left parietal lobe called the supramarginal gyrus. Broca's area is known to be involved in speech production. The supramarginal gyrus is known to be associated with language comprehension. And that would be over here. Brain scans carried out during the performance of visuospatial tasks show activation of quite different brain areas. Working memory tasks involving object recognition and visual catch produce activation of the left parietal and inferior temporal cortex. Spatial working memory tasks involving the visual buffer cause activation of the right dorsal, prefrontal, parietal, and occipital lobes. These findings are consistent with the known functions of the dorsal and ventral perceptual streams, since the regions activated during object recognition are involved in the ventral stream, the what pathway. The regions activated during spatial working memory tasks are associated with the dorsal stream, the where pathway. What do you need to remember about this is that we can visualize where all of these things take place, not remembering that, we can remember the where and the what pathways, the where and the what pathways. We saw this in chapter 2. The central executive involves many different functions, so it is not surprising that a number of different brain areas are involved, depending on the task in question. Brain scans suggest that most central executive tasks tend to involve activation of the prefrontal cortex together with the parietal lobes in certain specific CE tasks. CE, central executive. Okay, now this is the frontal cortex. Prefrontal cortex is right here. There we go, right in front. And that's the end of the chapter. Interesting chapter. A lot of it was speculative, and of course that kind of bothers me a little bit. Yeah, I'll see if I can find some questions to ask you about this chapter. Kind of a short one. See you next week for chapter 6.